বন্ধন. At first, happy Rakhi to all my viewers, all my friends, and all my sisters and brothers. I hereby tie this Rakhi on your wrist to protect you from the negativities and bring happiness and prosperity in your life. Today's goal of this lecture. Today I will see one question about annihilating polynomial. Actually, this concept, annihilating polynomial, this concept is very important for any competitive exam. So, today I will discuss one question about annihilating polynomial just as a review. The question is T be a linear transformation which is defined from R4 to R4 such that t square plus t plus I times t minus 2i equal to 0 and t square plus t plus 2i times t square minus 4i equal to 0. That means these two are annihilating polynomial because these two polynomial annihilates the linear transformation t. Then which of the following statement are false? Option 1, t is diagonalizable over R. Option 2, the characteristic polynomial of t is x minus 2 to the power 4. Option 3, the characteristic polynomial of t is x square plus x plus 2 times x square minus 4. Option 4, for every R, the linear transformation which exists from S from R4 to R4 such that ST equal to TS. Which of the following are true option? All of us know the minimal polynomial of any linear transformation is the monic polynomial of least degree such that MTT equal to 0. That means it divides every annihilating polynomial. And since given t which is defined from R4 to R4 such that t square plus t plus I equal to 0 and t minus 2i equal to 0 and given t square minus plus t plus 2i times t square minus 4i equal to 0, that means px equal to x square plus x plus 2 times x minus 2 and qx equal to x square plus x plus 2 times x square minus 4. These are both annihilating polynomial of the linear transformation t. Okay, that means this is the annihilating polynomial. And since minimal polynomial divide every annihilating polynomial, that means MTT divide px, also MTT divides qx, where MTT is the least degree monic polynomial. That means what would be the minimal polynomial of this polynomial? Here the least degree which divide both px and qx, this is only x minus 2. That means MTT minimal polynomial is x minus 2. I have done one wrong thing. Since this is the px, that means this is would be mtx, this is would be mtx, this is x mtx, so this is x minus. That means mtx equal to x minus 2. That means that imply mtt equal to t minus 2i. This is the minimal polynomial. And since mtt equal to 0 means since mtx equal to x minus 2, that means mtt equal to 0, that means t minus 2i equal to 0, that imply t equal to 2i. Now let's see the option about t is diagonalizable over R and the characteristic polynomial about t. We all of us know t is diagonalizable over R if t has minimal polynomial minimal polynomial has distinct non-repeated linear factor. If the minimal polynomial has distinct or non-repeated linear factor, then t is diagonalizable over R. Here only one factor t equal to 2i. If there exists distinct non-repeated repeated linear factor, then t is diagonalizable over R. Since there exists only one factor t equal to 2i, so t is diagonalizable over R. Okay. Option 1 is the right option. T is diagonalizable over R. Next option about characteristic polynomial. Obviously, characteristic polynomial would be x minus 2 to the power 4. This is not characteristic polynomial because we all of us know all eigenvalue of t are roots of minimal polynomial. Since in minimal polynomial only roots are 2, so cat t would be x minus 2 to the power 4. Since this is the linear transformation from R4 to R4. So option 2 is a right option. This is not true. This is not the root of minimal polynomial. And option 4 imply for every R linear transformation S R4 to R4 such that St equal to Ts. There exists linear operator S from R4 to R4 such that Stx would be x times Tx. Here Tx equal to 2x. That means this is equal to 2 times Sx. Similarly, Tsx equal to t times Sx, and this is would be 2 times Sx. So obviously St equal to Ts. This is always true. So option 4 also right option. That means option 1, option 2 and option 4 are the right option. Next question. This is also very conceptual question. The question is, let V be a vector space over C with dimension n and T be a linear operator from vector space to vector space, be a linear transformation with 2 as an eigenvalue. That means T which be a linear operator from vector space to vector space which has 2 as an eigenvalue. Then which of the following are true? Option 1, t minus 2i equal to 0. Option 2, t minus 2i to the power n minus 1 equal to 0. Option 3, t minus 2i to the power n equal to 0. And option 4, t minus 2i to the power 2n equal to 0. Here t be 2 as an eigenvalue. We all of us know if lambda belongs to V, then if lambda is an eigenvalue, then Tx equal to lambda x. That imply t minus lambda I x equal to 0. That imply t minus lambda I to the power mx equal to 0. That imply t minus lambda I to the power m minus 1 x, this is not equal to 0. But t minus lambda I to the power mx equal to 0. Now notice the option. Since 2 as an eigenvalue of this operator, that means t minus 2i to the power n x always equal to 0. That means option 3 is the right option by the definition. But t minus 2i to the power n minus 1, this is not equal to 0. So option 2 is a wrong option. Now let's see one example. Here, since 0 is an eigenvalue, so consider this operator 2 1, consider this matrix 2 1 0 0 2. Notice here 2, consider this matrix is A. Notice 2 is an eigenvalue of the matrix A. And notice here A not equal to identity. Identity means here A not equal to 2i. That means T not equal to 2i. That means if we consider this matrix where 2 is an eigenvalue, then I have got T not equal to 2i. Therefore, by this matrix, we can delete this option is wrong option. Also, notice here by this option we can also delete this option, because here if we, this is the 2 cross 2 matrix, that means n equal to 2. So T minus 2i to the power n minus 1 means here n equal to 2. That means T minus 2i to the power 2 minus 1, that means T minus 2i. This is equal to 0 1 0 0. And this matrix is not equal to 0. So by this matrix we can delete this option also wrong option. And since T minus 2i to the power n equal to 0, by definition, that means obviously by definition T minus 2i to the power 2n also would be equal to 0. That means option 3 and option 4 is a right option. I hope my all viewers have understood this question clearly. Okay? OA.